Hello. Today I'll go over Chapter 7, Pivot, Unpivot, Grouping Set, Cube, Rollups. These are useful functions that allow us to create reports. Let's look at this one here. Sum and the partition by employee. So run date, by running this one here, uh, same as the selecting column, second column, third column, but there's a function called partition by and order by and unbound and preceding. So that will create the run this column, which is the right there. So what happens is that you have a record here, 1614.88. Then it comes up adding up the number. And if you add these two numbers, it comes out like this. Basically, it adds number up to that certain row. So you see, if you combine these three values, that come out to this. So it would be, this is the summary total of up to this number. So you can see all these here. And if you go up to the 2, see the number, it starts again. So it doesn't accumulate if employee, a new employee ID, because the partition by is employee ID. So when you look at this, the new employee ID, so it starts the number again from the start. So that's why you see 1176 and you see 1176. And you combine these two numbers, then you add up to this number. That's what the partition means, and unbound preceding this. Let's look at other thing here. The values. We can look at this one here, row number. Is see the numbers, it changes increments one by one, which is row num over value. So as the value, new value comes in, the number increase one by one. Let's look at the rank. What is the difference between rank and row number? See here, 47. Okay, let's look at this number here. The number, the value is same value, but row num increases, whereas the rank, it stays the same way, 33. 33 again. So rank, but when you look at the next number, 33, 135, then it changes to 135. So rank is the same if the value is the same, whereas row num increases one by one. Let's look at the dense rank. Dense rank is, you see the numbers is 1. The end title, this one is the column splitting all these numbers, 830 rows. So it's splitting by 10, but so it divided by the 10, meaning after 83 records, the end title will change. Here. So after 83 records, it changed to be 2. So it basically splitting total number by 10. So if you divide by 11, you know, just change it to be 11. So partition by customer ID. So after a new customer here, 1, 2, 3. So this customer 1, it goes up to 1, 2, 3, 4, 5, 6. Then this is a new customer, so it starts again 1, 2, 3, 4, 5, 4. And new customer, third customer ID, so it starts with the 1, 2, 3 again. Compare with the distinct. The row num, so let's look at the distinct. This is the distinct and combined with the row num over value. Look at the 36, this one here, and look at the so it shows the distinct, and it shows the $36 and $36, but it goes 7 and 8. It's not skipping it. Whereas if you combine without the distinct, so this one is the 36, and the other one without the 36. So here it's not repeating it. So if you have distinct, it will show repeating 7, 8 because that has a 36, 36 again. So whereas without the distinct, it will show only once. So it's not repeating it. So 45, when I look at the 45, you see only once. 45, then it's repeating again. So distinct, when you apply with the distinct, this will be repeated. The number, the value will be repeated, and so is the row num. Row num will increment 1, whereas this one, without the distinct, it will stay the same, one single value there. Lag lead function, when you need this, well, so let's look at the what the lag and lead means. Lead, so value, you have a value here, 814 this, and the previous value is null because this is the first value. What is the next value? Well, it will show next value to be next one here. So previous value is pointing to previous value, and the next column is pointing to the next value will be shown in the next row. So this is a very useful tool because many number of reports you create that requires the previous value and next value. So lead is something that you is built-in function that shows the next value of a row. Lag means the previous value. So it's got a linked list you can make. How about the first val and the last val? This is all these are built-in function in 2012 SQL databases. Let's look at the first val and the next val. So look at the first value is 814 and 50 cents, and next and last value is this. So what does it mean? Well, when you grab the this is partitioned by customer ID. What it means is that it gets the lowest value of this, well, the first value of the list, and the last value of the list for this particular customer ID. So by looking at this, you can see the first order the customer purchased, and you can see the last item the customer purchased side by side. So this is a tool that allows you to create a nice report. So all this can be done without using the applications. You can just generate this, and the reporting tool will just grab directly from this list. So this is the partition by customer ID and order by the order date and order ID. So that allows you to grab the latest first order and the latest order. Now let's look at the column is called total value and the total value customer total value. So this column is coming from this, and this column is coming from this. So this is the sum. So sum over the empty parenthesis and sum over partition by customer ID. So we know this is partition ID, which is coming from here. So you can look at this one here, total. So what it means is that this customer, if you combine all these four values, 2, 4, 6 values, then it adds up to the $4,273. And what is the total value without any partition here? What it means is that it's a total. If we add all these values in this table, it add up to the this value. Why is it useful? Well, later we will see it. By having this, you know how many, what is the total purchase this customer made, and these are the individual purchases this customer purchased. And this one is the total sale associated with the these whole thing there. So next one here. So by having this, previous one it showed actual value. Now, when this is the same as the before, similar, but this time it shows the percent. So what is a percent? Well, the percent all. This means the what is the the rate of this 814 and 50 cents over total sales happened. So this is a 0.064%. And what is the rate for within the all the items this customer purchased? So it's the 19%. So 19% out of total purchase by this customer one is this, and this is the this item the percentage over all the things all the customer purchased. So this is the rate percent. So simply you have this one here and over. By having this, you get a percentage compared to this one here. This one gives you the actual value, but on the bottom one, by having the over this, you see actual percent. Let's look at this one here. the sum over partition by employee ID. So it's grouping by the employee ID and order by this run value. So here you see on the you add this number to this, then it comes up to this number. So if you add these two numbers, you see on here, similar to above one. So it starts again. When it encounters the next employee ID, then its run value going to be start again, similar to the above one. Pivoting data. Let's look at this one here, pivoting after creating this table, it will add 11 records, as you see here, 11 records added in this orders table. Now let's look at the grouping by employee and the customer. So grouping, it gives you employee and A, customer. So grouping by employee and customer ID, employee and customer ID, then you get the this value here. Now, if you do like in the past, without any using standard, well, without any using the built-in functions, the standard would be the you have a case and sum and all these you have to do coding like this. When customer equal to this, then this, or C, etc. All this. So this is the old way to do that. You have employee ID, and if you have A, B, C, D, then you have all these, because case will grab A, B, C, D. This is basically a column there. It's employee, case, then it adds up. Now, in the new way, would be much easier. So A, B, C, D is pivoting. So let's look at how the pivoting is working. So A, B, C, D, this is same as the one you saw in the previous one here using case statement, but you don't have to use the case statement in here. Native to SQL pivoting. So you have a column A, B, C, D, then you grab pivot with the pivot. So select employee ID, customer ID, quantity, orders, and S, D, and pivot some quantity for customer and this. So you're pivoting instead of having original way employee ID, customer ID, quantity, columns on the right the columns you are having A, B, C, D as a columns. So because you're using pivot, pivot turns the values. Now let's look at this one. The same thing here. Pivot, instead of having A, B, C, D, applying the 1, 2, 3. So by having 1, 2, 3, 1, 2, 3, so employee ID, customer, quantity, so it's pivoting for employee ID. So based on the employee ID, it puts the number. Customer ID, employee ID, pivoting quantity. So all these are nice. You can generate, see on here, A, B, C, D, A, B, C, D. 1, 2, 3, 1, 2, 3. So it's pivoting. So you are pivoting using this built-in function. So let's look at unpivoting. Unpivoting is basically opposite of pivoting. So let's look at this one here. This one is creating the table called employee customers table, and adding these are the columns, and adding a value into this table. So insert into this table. What kind of value will be inserted? Well, you have a pivot inside here. So whatever you select from here is added into the table. So this value is added into the employee customer table. So when you create the table, it's already aggregated and also as a report. So on here, it's already a report. So employee customer report. Now selecting from So when you have a table with this, so original table is employee customer table, which has all these rows inside there. Bottom one here is using the above table here, employee customer table, and it's using the A, B, C, D, and then A and cross join with this. Then you see A, B, C, D, A, B, C. So 1, 2, 3, 1, 1, 2, 2, 3, 3, 3. So basically, this condition case statement is pulling 1B. So 1B, 1C. So that's why you see 2, 20, 34 is coming from there. And employee 2, you see how many rows with columns with the values 1, 2. So when you look at the employee 2, it's A, B, employee 2, A, B, and this is number. So instead of having this matrix, you can generate a report similar to like this. So employee 3, 1, 2, 3. So you see the A, C, D associated with the employee 3. So that's why you see 3 columns there. 20, 22, 30, 20, 22, 30. All these are useful because the number of times you create a report, business managers, people, they request a certain report, and this is the built-in SQL Server built-in reporting tool that's easily generate, visualize how many customers purchased the number of items and which what kind of items they purchased. Easily they can generate it like this. So this is another pivoting. Simpler way, instead of having all these case statement there, if you run this, it will easily generate, instead of writing all these select and all these case statement there, it can easily do that by using the unpivot. So this is the equivalent to above the case statement there. You don't have to use all this less coding, basically. Select employee customer ID and quantity, then you use the pivot. So let's look at this one here. Simply, you can run this part. Orders quantity. Oh, it doesn't exist. Customer ID. Yeah. So this pivot and quantity. So customer ID A, B, C, D, S, U. So look at this one here, same as above. Much less coding. Let's look at the grouping sets. So this one is the select employee ID, customer ID, sum of the number that is some quantity, and grouping by employee ID and customer ID, then you get this value here. So you're grouping employee ID, customer ID, summary, employee. So grouping employee ID to, and you get the customer. So sometimes it's nice to have order by, and same as this, then you can easily see. So much easier to read when you have order by. So you have a select employee ID, customer ID, sum, and grouping by employee ID, customer ID, then you get number. So the employee 1 associated with the B customer sold the 20 items. Same employee 1 associated with the customer ID C sold 334 items. So that's how the grouping by works. So it groups by the employee ID first, then it groups by the customer ID. So you can see how many items the employee 1 sold to the customer B. And this one here, grouping by employee, then you get the simply get the how many items sold by the employee 1, 54 items, and employee 2 sold 79 items. And this one will give you customer 1 purchased 72 items, customer B purchased 47 items, because you have a customer ID and how many items and grouping by ID, customer ID. So it tells you how many items the customer purchased. Next one is the you have a sum of quantities. So it's the total items sold by this company. How many items sold? Well, it's looking at the orders table, which gives you the number of items sold, and you're grouping nothing. So that means that all the items sold by this company. So 205 items sold. So let's look at this whole thing, whether instead of running multiple queries, and why not create a nice here. So what does it mean? This means the by looking at this, it shows you the employee 2, like Corey here. union all. We learned about the union all. So this is the basically grouping them, uh, above with the union all. So it gives you the a breakdown. So what it means is that number two, customer A purchased 72 items. Customer B purchased the 47 items. Customer C purchased this. So it's kind of by having all this union, you see all here. But there's a better way to create instead of union all and joining all these multiple queries. It can do better by having much better one single query that is equivalent to all this union all stuff there. By instead of having 1, 2, 3, 4, 5 unions, you can have a simple one here like this, which is equivalent above. It gives you the same thing, same result. Customer A purchased 72 items. You can see the what items employee 2 sold 52 items to customer A, and employee 2 sold 20 items to customer B. And you see the subtotal also shows up here. So it's one single query that will generate very nice, useful report business people can easily understand. So it's like a subgrouping. Coding is much less just a simple query with the grouping set, using grouping set. Compare this to above. So long query, instead of long query, you have a grouping function that grabs all these nicely single one query. So this means the better performance, because above one is it goes through the reading it 4 or 5 times, but this one grabs only reads only one time. So better performance. So this one is the using the cube function. So what is the difference between this and above? You have a grouping. Is there any difference? Instead of having this one was much better than the previous one, but we have a better one there, which is a cube, and it has the group by cube employee ID, customer ID, and it gives you the list. So this is much better than the above one here, right? Much less coding. It can have a grouping set, but it can also have a cube. Let's look at the roll up, and look at the year and this column here, sum. So you have year is a function that extracts the year from this order date. Month is the function that extracts the month. Date is the function that extracts the date. And sum is the total number of quantity. And it's grouping by roll up date and year. So you can see 22 records shows up. This. So let's look at the column called the year. So year is the 2007. So this is the that year's sales report. Basically, you see the order a month. There's a April. You see the April 18th. You see 22 items sold, and this is the sub report, which is the in the April there are only 22 items sold. Let's take this one here. In August 2nd, there are 10 items sold. So total number of item is the 10 in the August. In December 24th, sold 32 items. So total number sold in December is 32. So you have in 2007, 64 items sold. So you have a nice report. Let's look at here. 2008, January 9th, it sold 40 items. 18th January, sold 14 items. So add up to the in January total sale would be 54. So it's a lot better with this simple a query. This one here, it will give you nice report that tells you how many items per month sold, per year sold. So if you go down all the way here, on the bottom one here, it gives you the total items sold for entire from the since the beginning of the business. Because this 205, that is total number sold from the 2007 up to 2009. Grouping and grouping ID function. So this one gives you the cube and same as the above we went through there. Instead of having this, 15 records shows up here, 15 records from this select statement there using cube. Let's look at the grouping and the function. Grouping customer ID, and look at this column here, grouping employee, grouping customer, this one here, this is this one here. So what does it do? Well, it's using same as the above, except it's adding these two columns. So what's the difference between this and this? Well, the data set would be same here as above here, but it will give you the grouping. So let's look at what it does. Here it shows the 1. 1 means it will show grouping employee ID. So this is 1 indicating the for this particular employee sale. So this one, it will show you 1 indicating this to the 72 items sold here, which is the grouping employee ID. Now, if you go down here, how does the grouping customer ID, how does it work? So look at this column here. You see 1. So this means the indicating this customer 1 sold 54 and 2 79. So if we have both, that means the total items sold from entire year 2007 and 2009. So this is a indicator. Sometimes you add these for business web applications. You generate, rerun this one here, and the web application will grab. It will say it needs to know which one is the total value. So the application can easily see if these two values are indicated to be 1, that means it's total value of this. If it's indicating this, then it will indicate the this employee's total for the associated with the customer D is 30 items sold. So this is the indicator that allows web applications or third application tool to put some titles like description. So if it's indicating 1, that means the something employee the for this particular employee's total, and if it's 2, then it's a total value of all the items sold. Let's look at the next one here. Look at this column, grouping ID. Grouping ID is a function that's grouping employee ID and this. So how does it different? 15, 15. So instead of have on the previous one here, we didn't see 2, but this one grouping ID shows a 2. So what does it do? Well, 2 means the different flags, because we have employee ID and customer ID, and it has the 3 also indicating. 3 indicating the, instead of having 2 columns on previous query, you can have a grouping ID set, which is indicating 3 means is the total value of all these. 1 means the sub, 2 means the sub for the customer. So customer total C is 56 items sold. And if whenever you see 2 means the customer D is purchased 30 items. So 1 is indicating employee ID. So employee 1 sold 54 items. Employee uh, employee 2 sold 79 items. So it's an indicator. This will use an indicator saying how many items particular customer sold. See here 2 means the employee ID is true. So C customer sold purchased 56 items. 1 here indicating the employee. So employee 1 sold 54 items. Employee 2 sold 79 items. Employee C, employee 3 sold 72 items. So this is useful because this allows you to indicate the actual value. So you don't have to worry, you don't have to know how many items, whether it's a grand total or subtotal, because you see the 3, which means the grand total. This 2 means the subgroup of C. 1 means subgroup of employee.